Section 4.3, the atom. All the elements listed on the periodic table are made up of atoms. As we discussed, an atom is the smallest particle of an element. Imagine you're tearing a piece of aluminum foil into smaller and smaller pieces. Now imagine you have a microscopic piece so small that it cannot be divided any further. Then you would have a single atom of aluminum. The concept of atom is relatively recent. Although the Greek philosophers in 500 BC reasoned that everything must contain minute particles that they called atomos, the idea of atoms did not become a scientific theory until 1808. Then, John Dalton developed an atomic theory that proposed that atoms were responsible for the combinations of elements found in compounds. Dalton's atomic theory. All matter is made of tiny particles called atoms. Number 2. All atoms of a given element are identical to one another and different from atoms of other elements. Number 3. Atoms of two or more elements combine to form compounds. A particular compound is always made up of the same kinds of atoms and the same number of each kind of atom. Number 4. A chemical reaction involves the rearrangement, separation, or combination of atoms. Atoms are never created or destroyed during a chemical reaction. Dalton's atomic theory formed the basis of current atomic theory, although we have modified some of Dalton's statements. We now know that atoms of the same element are not completely identical to each other and consist of even smaller particles. However, an atom is still the smallest particle of any element. Although atoms are the building blocks of everything we see around us, we cannot see an atom or even a billion atoms with the naked eye. However, when the billions and billions of atoms are packed together, the characteristics of each atom are added to those of the next until we see the characteristics we associate with the element. For example, a small piece of the shiny element we call nickel consists of many, many nickel atoms. A special kind of microscope called a scanning tunneling microscope produces images of individual atoms. Figure 4.7. Images of nickel atoms are produced when nickel is magnified millions of times by a scanning tunneling microscope. Electrical charges in an atom. By the end of the 1800s, experiments with electricity showed that atoms were not solid spheres, but were composed of even smaller bits of matter called subatomic particles, 3 of which are the proton, neutron, and electron. 2 of these subatomic particles were discovered because they have electrical charges. An electrical charge can be positive or negative. Experiments show that like charges repel and push away from each other. When you brush your hair on a dry day, electrical charges that are alike build up on the brush and in your hair. As a result, your hair flies away from the brush. Opposite or unlike charges attract. The crackle of clothes taken from the clothes dryer indicates the presence of electrical charges. The clinginess of the clothing results from the attraction of opposite, unlike charges. Structure of the atom. In 1897, J.J. Thomson, an English physicist, applied electricity to a glass tube, which produced streams of small particles called cathode rays, because these particles were attracted to a positively charged electrode. Thomson realized that the particles in the rays must be negatively charged. In further experiments, these particles, called electrons, were found to be much smaller than the atom and to have extremely small mass. Because atoms were neutral, scientists soon discovered that atoms contained positively charged particles called protons that were much heavier than electrons. Thomson proposed a plum pudding model of the atom in which electrons, negative, were randomly distributed in a positively charged cloud, like plums in a pudding or chocolate chips in a cookie. In 1911, Ernest Rutherford worked with Thomson to test this model. In Rutherford's experiment, positively charged particles were aimed at a thin sheet of gold foil. If the Thomson model were correct, the particles would travel in straight paths through the gold foil. Rutherford was greatly surprised to find that some of the particles were deflected slightly as they passed through the gold foil, and a few particles were deflected so much that they went back in the opposite direction. From his gold foil experiments, Rutherford realized that the protons must be contained in small, positively charged regions at the center of the atom, which he called the nucleus. He proposed that the electrons of the atom occupy the space surrounding the nucleus, though of which the particles traveled undisturbed. Only the particles that came near the dense positive center were deflected. If the atom were of the size of a football stadium, the nucleus would be about the size of a golf ball placed at the center of the field. Scientists knew that the nucleus was heavier than the mass of the protons, so they looked for another subatomic particle. Eventually, James Chadwick in 1932 discovered that the nucleus also contained a particle called a neutron, which is neutral. Thus, the mass of the proton and neutrons in the nucleus determine its mass. Mass of the atom. All of the subatomic particles are extremely small compared to the things you see around you. One proton has a mass of 1.673 times 10 to the negative 24 grams, and the neutron is about the same. The mass of the electron is 9.110 times 10 to the 28 grams, which is much less than either proton or neutron. Because the masses of subatomic particles are small, chemists use a unit called the atomic mass unit. An AMU is defined as 1/12 of the mass of a carbon atom with 6 protons and 6 neutrons, a standard in which the mass of every other atom is compared. In biology, the atomic mass unit is called the Dalton, in honor of John Dalton. On the AMU scale, the proton and neutron each have a mass of about 1 AMU. Because the electron's mass is so small, it's usually ignored in atomic mass calculations. Table 4.5 summarizes some information about the subatomic particles in an atom. The proton has a charge of +1 and is found in the nucleus. The neutron has no charge, is found in the nucleus, and an electron has a charge of -1, is found outside the nucleus.